notes, you're going to find that we are taking 4.2 in several pieces. I do that 4.2, 4.3. We are breaking it down into several pieces. Okay? Now, this is kind of your 4.2 introduction. Honestly, I don't think I'm teaching you anything you don't already know, because this should be geometry based. Okay? And trig is very geometry based, so we do have to remember some of our geometry. So, Ms. Byers, who's typed the notes up, referred to SOHCAHTOA as the Great Indian Chief. What do you guys know about SOHCAHTOA? I was waiting to see what he was going to come up with. SOHCAHTOA, 3 sections that represent what? Sine, cosine, tangent. Okay. Sine. What's that so part represent? Opposite hypotenuse, meaning the sine of an angle is equal to the opposite side over the hypotenuse side. So thus the abbreviation SO, S-O-H, opposite over hypotenuse. Now, let's take a minute before I go any farther. We have a triangle. Obviously, to even talk SOHCAHTOA, it has to be a right triangle. If it's not a right triangle, these trig functions don't apply like this. Notice right here is theta, which is the angle in question on this one. If that is my angle, where is opposite? Do you know? Okay. Opposite in this particular case is the vertical line. It's the line that is opposite the angle and does not touch the angle, correct? And so, if your angle was positioned differently, obviously opposite would be in a different location. But it is the leg that does not touch. Okay? Where is hypotenuse? Okay, longest leg in the triangle. It's also what? Okay, the run. If we talk about a right angle, the hypotenuse is the one across from the right angle. It's the one that does not touch the right angle. I don't know how you guys remember this. Okay. And we haven't gotten to it yet. But what's that third side? How do we refer to that third side?
Adjacent.
Okay. It is the short leg of a right triangle, but talking trig functions, this is the adjacent leg. Okay. It's the adjacent leg because when this is our angle in reference and that we're referencing, it is the side that actually touches that angle. Okay? Sound familiar? Okay. So if you're doing the sine of an angle, you put the opposite side over the hypotenuse. Okay, what's cosine? Okay. Adjacent of hypotenuse. In SOHCAHTOA, it's the cos, however you want to say that. And that is adjacent over hypotenuse. I'm struggling. I keep spelling hypotenuse wrong today. Okay. And tangent. That's TOA. That's opposite over adjacent. Okay, that should be familiar from geometry. Okay, that should definitely be familiar. Now, did you guys talk about the other 3 trig functions? Cotangent, secant, cosecant? Okay, so that's new to you? So, first of all, I don't know, honestly. I'm not saying you were necessarily. I'm not necessarily, I don't remember if you are, I'm not sure if it's necessarily supposed to come up. Okay. So, but it does come up now and you are responsible for now. Okay, so first of all, cotangent. Which of my original three functions do you think this pairs with? Tangent. And the relationship between tangent and cotangent is that they are reciprocals. So if you know tangent is opposite over adjacent, what does that make cotangent? Adjacent over opposite. Okay. From here, we're going to work our way up, and secant pairs up with opposite first letter, cosine. Secant and cosine are reciprocals. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And then the last possibility to pair up, cosecant. Match it with the opposite letter is what I think. And so cosecant pairs with sine. If sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. Okay? Sock it away to memory right away, guys. You've got to know those. Okay? So everyone has their own memory techniques, right? My memory technique, is that the cosine goes with the secant, it's opposite first letters. So the cosine and cosecant do not go together. I have to flip them. I don't know how you want to remember it, but figure out a way. No idea. Okay, so you would have done some of this in geometry. Use the following triangle to determine the 6 trigonometric functions of the angle theta. That means you owe me 6 answers on this problem. I need to know what sine theta is. Are we done? Okay, I need to know sine theta. I need to know cosine of theta. I need to know tangent of theta. I need to know cosecant of theta, secant of theta, and cotangent of theta. First of all, theta is our variable. That represents the angle in question. In this case, our angle is given right here. Okay, that is the angle in question. And notice my abbreviations. Those are your standard abbreviations. You guys already know sine, cosine, tangent, right? Cosecant is at CSC, secant is SEC, cotangent COT. So, tell me about the 3 sides of this triangle before we get started. What do we know? Where's my opposite? Okay. Anytime in this particular problem based on that angle, opposite is 2. What else do I know? What's that 3? Adjacent. Am I going to need to know that 3rd side? Yeah, I'm going to need to know my hypotenuse. Any thoughts of how I get it? Okay, Pythagorean theorem. A squared plus B squared equals C squared. So 2 squared plus 3 squared equals C squared. C squared is 13. So what is C? Square root of 13. Please leave it as the square root of 13. I do not want a decimal. Okay? We're not going decimal mode. We're staying in radicals and fractions. Okay, guys. What is the sine of theta? No, not what I'm meaning here. What is the sine of theta? Okay, so theta is right here. Okay, theta is the angle. So what is the sine of the angle theta? So what is sine in relation to this angle? 2 over the square root of 13? Because what's our saying for sine? Opposite over hypotenuse. What is the cosine of angle theta? There's your theta. What's cosine of this angle? 3 over the square root of 13, because my phrase is adjacent over hypotenuse. What is my tangent of angle theta? Opposite over adjacent, 2 over 3. Now, if you set it up like I did, I would like to argue we've done all the hard work. What's the cosecant of theta? Square root of 13 over 2, because the cosecant matches up with sine, opposite first letters. So if we've already found sine to be 2 over square root of 13, then cosecant is square root of 13 over 2. What about secant then? Square root of 13 over 3, because it's the reciprocal of cosine. And what about cotangent? Okay, 3 over 2, because it's reciprocal of tangent. Guess what? We're done. Okay. Do you have to rationalize? Obviously not. I did not rationalize. Okay, example 2. Slightly different setup here, but we will essentially be doing the same thing. Okay? Assuming that theta is an acute angle in a right triangle, find the remaining trigonometric functions given that the cosine of theta is 5/7. So what do we mean find the remaining trigonometric functions? Find everything except cosine. So how many answers am I expecting here? I'm looking for 5 answers. Okay. How does them providing cosine help me? We know that the idea of cosine is adjacent over hypotenuse. So if you know adjacent over hypotenuse, can that help us? Yeah, because we essentially know 2 of our 3 sides of the right triangle. I'm going to draw myself a triangle. Obviously, I drew a right triangle. Officially, you can make theta whichever of the other 2 angles you want. I'm going to use what I used earlier. So, if this is theta, where are 5 and 7? Okay. Because 5 is adjacent, that is the side below. 7 is the hypotenuse. So that is that side right there. Are we going to need to find that other side? Yeah. How do we find my missing side? Pythagorean theorem. So again, this time I'm going to do 5 squared plus b squared equals 7 squared. 25 plus b squared equals 49. B squared equals 24. So that means B is the square root of 24. If you simplify the square root of 24, what is that? 2 square root of 6. Because 24 is 4 times 6. Pull that perfect square out. Okay, so 2 square root of 6 is my missing side over here. That is going to be the opposite side. And what do we need to find? Sine. We already know cosine. We're going to have to find tangent. We're going to have to find cosecant, secant, and cotangent. If you're questioning what I did, I set them up in the same order I set up last time, except I just left my cosine slot blank. Okay. Sine. What you got there? Opposite over hypotenuse, so 2 square root of 6 over 7. Tangent. What do you got there? Opposite over adjacent, so 2 square root of 6 over 5. Okay, now flip them. Cosecant then is what? Seven over 2 square root of 6. Secant? You're taking the fact that cosine was originally 5 over 7 and flipping it, doing 7 over 5. Cotangent. 5 over 2 square root of 6. And that is your geometry review for the day. I guess geometry review, and I added in, right? I added 3 new ones, but.
How long will it take us to get through 4?
Homework is page 335, 2 through 18 evens. Before I turn this off.